Answer key for AP review questions. All right, find the limit as x approaches 3. Well, we plug it in and we get 0 on the bottom. So we go, uh-oh, problem. So we do that factoring thing I've read so much about. And we say, oh, cool, we can cancel this out. Now we can plug in 3 and we get 5. Now, the other thing we can do is graph it and say, hey, look, 5. So whatever works. Shouldn't be 5 answers, but there are because I do not feel like changing them. There it is. Find the limit as x approaches 2 from the positive side. Well, I don't care about this. I care about this. So plug in 2 and I get 5/3. Done. Now, I've cheated a little bit. You almost always want to graph this, but in this case, it really does tell you. It's just testing, do you understand what that little plus means? It means what's going on when we come from the right, and that's greater than 2. With the following lines is a horizontal asymptote. Okay, horizontal means limit as x goes to infinity. So we want to do, and we should be careful, think about plus or minus infinity and see if that causes problems. Now, this is x to the third of x to the third, so it's just going to go to 3x to the third over 2x to the third, which is 3/2. So y equals 3/2. Not 3/2 x, 3/2. Good little screw with the answers here. Which of the following values average rate of the interval? Oh boy, we've done a lot of this. Plug in 3, square root of 3 plus 1. Plus square root of 0 plus 1 over 3 minus 0. 2 plus 1 over 3. 1. That. 2 minus. Radar went off in my brain that something was wrong there. Notice the answer wasn't here, so I would have probably gotten lucky. Disappointed. What's following is false for the function. Now, this is a very typical AP question. I hate them, but you know, it is what it is. So let's see what's going on. Limit as x approaches 4 exists. F of 4 exists, which is false. So let's go through them. F of 4 exists. Is that false? No, that's very true. So we can cross that out. I'm just doing this as a teacher. You don't have to worry about this. All right, does the limit as x approaches 4 exist? Now, I actually don't care what's happening at x equals 4. I care about the left and the right below and next to it. So 3/4 times 4 is 3, and -4 plus 7 is 3. So yeah, that's true. Because limit as x approaches 4 from the negative side equals f of x equals limit as x approaches 4 from the positive side. So we'll cross that out. Limit as x approaches 6 exists. Yeah, 0.6. Ooh, I gotta be careful. Plug in 6, -6 plus 7 is 1. Yes, limit as x approaches 6 from the negative side of f of x equals limit as x approaches 6 from the positive side of f of x. So it's true. Limit as x approaches 8 from the negative side. Yep, that works because that's just coming from here. It's just 1. True. Which means this is our example. F is continuous at x equals 4. Plug in 4, I get 3, 2, 3. So it's got some graph at 3, then there's a hole and 2, and then keeps going from 3. It actually would look something like this. 4, 1, 2, 3. There's a dot here, and then there's an open hole here, and an open hole here, something like that. Although I don't know what the graph looks like. That's a great question. See if you understand what the heck's going on. Yeah, that's good stuff. Which follows the equation with the tangent line at x equals 2? Well, we need the slope. So the slope is going to be negative 2x at x equals 2. Slope is negative 4. Plug in 2, we get 2 comma 9 minus 4, 5. So y minus 5 equals negative 4. X minus 2. Y equals negative 4. X minus 2 plus 5. Negative 4x plus 8 plus 5. Done. Free response. This is how all of the AP review problems are. Some multiple choice, some free response. Domain and range of F. Domain. I can't put in 0. So negative infinity to 0. 0 to infinity. Range. Graph it, and I find that the range is pretty much everywhere. Cosine just bounces around, but x gets really huge, really small, negative, positive, so negative infinity to infinity. Definitely recommend graphing this one. Is f even, odd, or neither? It's odd. Because if I plug in negative x, I get negative cosine of x over negative x, which is just cosine of x over x. AKA, if I graphed it, it has point symmetry. Simple enough. Find limit as x approaches infinity. Well, I do it my way. Other people do it their way. Cosine of infinity is somewhere between negative 1 and 1. Infinity, really big. Limit x approaches infinity. F of x, 0. All right. Now it's a right hand end behavior, blah, 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 blah. Yeah, I'm not getting into that. That's just how I do it. Okay, find f of 3. Kill. F of 3, 2 times 3 minus 3 squared equals negative 3. Find f of 3 plus h. I feel like they're setting up a difference quotient here. F of 3 plus h equals 2 times 3 plus h minus 3 plus h squared equals 6 plus 2h minus 9 minus 2xh minus h squared equals, I guess we should put the negative h squared first. What is this? 2x plus h. 3 plus h. That was weird. Yeah, that's right. So negative 6h, 2h is negative 4h. Minus 9 minus 3. Go. And then f of 3h minus f of 3 over h. Okay, so negative h squared minus 4h minus 3 minus 3 over h. See ya. Equals negative h minus 4. And find the instance rate of change, which would be the limit as as h approaches 0 of f of x plus h minus f of x over h, which plug in 0, we get -4. Derivative 2 minus 2x, I'll throw it over here. Derivative 2 minus 2x, plug in 3, 2 times 3 is 6, 2 minus 6 is -4. Long, oh geez, I apologize, I forgot to do that. Long way, short way. Oof, made a mess of it too. And forgot to show people. And I can't blame it on it being early in the morning. Yeah, what are you gonna do? All right, domain. Well, it's a pretty big domain. We can plug in anything except 3 and -3, I believe. So, yeah. The infinity to -3, union 3, 3, union 3 to infinity. Write an equation for each vertical asymptote of the graph of f. Plug in 3 or -3, so it's x equals -3, x equals 3. We're writing an equation for each horizontal asymptote. So limit action goes to infinity, f of x equals bigger power on the bottom, 0, y equals 0. Is it even, odd, or neither? It's odd. Graph it to be sure, but is f of -x equals f of -f of x. Bottom will always be positive, nothing happens, so the top just negative pops out front just like that. Find all values of x which f is discontinuous, classify each discontinuity as removable or non-removable. So we're looking at x equals -3 and x equals 3. So I'd have to graph this to get a good look at it. I believe these are just holes. I mean, they're asymptotes. So that means they are non-removable. I don't know. I really should have graphed these. I'm disappointed I didn't, but I don't want to take all the fun away. Here's another AP-esque problem. They throw this variable in here just to mess with you. So it's kind of fun. Find the limit as x approaches 2 from the negative side of f of x. Negative side right there. Limit as x approaches 2 of f of x. So we're just plugging in 2, and we're saying it's from here. So it's 2 squared minus 2a squared. And people see this limit and they start thinking of the difference quotient. Like, no. Nobody said anything about instantaneous rate of change. It's just a straight up limit. It's one of many, many things that makes calculus so hard. There's so much going on. A limit from the right. Well, from the right, we just, again, plug it in. 4 minus 2, 2 squared, which is 4 minus 8, which is -4. Find all values of a that make f continuous at 2. So again, I've seen this kind of problem before. They just do the whole 4 minus 2a squared equals -4. Subtract 4 from both sides, move it over. 2a squared equals 8. A squared equals shockingly a perfect square. Makes it continuous, so let's justify it. We should get -4 when we plug in over here. So 4 minus 2 times 2 squared equals -4, and 4 minus 2 times -2 squared equals -4. All right, find all the zeros of f. Now, I love this. I'm sorry. How do I find the zero? I could graph and pray, but you know what? I want to know when x to the third minus 2x squared plus 1 equals 0. I think I could probably guess that it's 1 from graphing. And reach into the toolbox and do this fun little thing. Oops, 1. So I get x squared minus x minus 1 to find all zeros. So we would get x equals 1, and then using Mr. Quadratic, I'd get 1 plus or minus square root of 5 over 2. Those are my zeros. Find a right end behavior model for f. So we'll just take the biggest powers. G of x equals x. And then determine the limit as x approaches infinity and negative infinity. Limit as x approaches infinity. So biggest power on top, infinity. It's going to get bigger and bigger and bigger. And the limit as x approaches infinity of f of x over g of x. And yeah, this is a little bit crazy and contrived, but they do this sometimes. It is just x to the third minus 2x squared plus 1 over x times x squared plus 3, which is 1. Same powers, coefficients are 1 over 1. Oh boy, hope you're ready for your chapter test, because it's going to get a lot harder after this, so do well on this test. Good luck and happy mathing.